We'll put the PA disabled jumper in. Otherwise we won't get much. Okay. And we will be using a two-tone generator for audio today.
All right.
And that goes into the phone patch input. Okay, so we got power, RF output, push to talk, PA disable, push to talk, audio. Okay. So we've got the RF going to a bird watt meter through a 30 dB attenuator to a variable attenuator up to the scope. I'll check the audio level out of the two-tone generator. About 40 millivolts RMS, that's fine. Okay, now we're loaded at 230 mils, and we've got 115 watts.
Sounds good.
Okay. Now let me get the scope sensitivity set. There we go. There's 4 dB of ALC. The scope is still having trouble triggering.
Okay. But it gives us a pretty good idea.
Yeah. Peak the exciter again. Load it for 230 mils. Oh boy. 125 watts at the bottom of 80 meters. Which is normal. Actually, 40 meters is the hottest band on these transmitters, but you get even more power on 80 meters. But the overall transmitter gain is highest on 40 meters. It's lowest on 20 meters, but you still get, rated power output. Go to tune. Whoop, whoop. Yeah, the 80 meter band, the exciter tuning is very sensitive. Can be hard to find the grid drive, the point. There it is. Dip the plate. Bring up the loading. Go to lock key. Redo the exciter tuning. Bring up the grid drive. That's okay, there's and then we've got 120 watts at 3.7 megahertz. Okay?
Good.
Let it rest. Don't want to burn out his finals. This has the same finals that had when I acquired the unit, but so I don't know their provenance, how many hours are on them, but they're putting out plenty of power. And when I looked at them, when I had them removed, when I first worked on this thing, they looked pretty good. So they're Raytheon 6146Ws, very high quality tubes. I wish I could find a source for more of them.
What does the W signify?
That's the militarized version.
Okay, so it's rugged.
Yeah. Yeah, I don't know specifically what the difference is, but yeah, it was built to a mil spec.
Good.
It's a dual impedance mic, and it's set for high impedance. But the reason I like this is the style, which is very similar to the Collins SM1 and SM2 microphones.
Absolutely.
But it's a far better microphone.
Okay. Well, this is what I'm offering Jerry.
Okay.
I'm offering it as a gift, so.
Okay. Now this is mounted. This base goes to the 664 microphone, and I modified the base to hold the 664A.
Okay.
And it's got the rare switch in the base, the push to talk switch in the base. This is I don't remember the number offhand, I'd have to look it up. So this is not the normal base that would be available with a 664A.
Okay.
Yeah.
I'm going to move in on the S3 here a little bit so he can see it. This is in your primary station.
This is my primary station. Yeah, this one is a real sweetie, cosmetically and electrically.
Good enough. Thank you. 7.1 megahertz.
$230 mils, and we've got 125 watts.
How nice. 20 meters.
Stand by here. Okay, what do we got there?
It's 100 watt, what's the scale? Full
Oh,
scale?
it's 250.
250?
Yeah, you're reading the top one. That's
Okay, yeah, about,
120 watts?
yeah, it looks like
Okay.
just under 125, yeah. Good, okay,
That's 14.1.
okay,
Okay, we've got the two-tone level set at 30 millivolts RMS, which is typical, a representative of the peak amplitude you'll get from high Z dynamic microphones. We'll key the transmitter and crank the mic gain up just to ALC threshold. And that's where you're going to start reaching full power output. And the mic gain control is at about 11 o'clock, which is normal. That's where it ought to be.